My name is Stefan Domedy, as already mentioned, heading a department of SISW, Siemens department here in India. And I would like to talk a little bit about operational excellence in the process industry. First of all, I have to thank all the previous speakers for their valuable input. I mean, this is exactly what we also focus on. And I just want to dive in a little bit more into the topic itself. As I'm from IT background right now, I would like to emphasize with some examples, some ways, and some focus which we are currently looking at. Let's have a look at today's challenges in overall view. If we have a look, and this was also addressed yesterday, we have to deal with numerous information. So the amount of information almost tenfolds every 5 years. And we had yesterday this example with respect to the transmitters, the amount of data these transmitters deliver per day. And this data is information up to now and needs to be converted later on into knowledge. What does this mean is, in a nutshell, if information is only available at an accuracy of 80%, let's say, the amount and the workload which has to be put in place to make it 100% is at least 40% higher than with 100% accurate information. This in return means operational excellence requires a certain information platform and as well needs consistent data throughout the whole plant lifecycle. If we have a look at today's market challenges, I just addressed also quality issues of as-built documentation of a plant. I mean, right now we have to deal with separate vendors, separate solutions, and in the end it has to suit all the needs for operational tasks. To combine all of these, to make them suitable and to gain all information at the same time, to execute and to decide with respect to maintenance and operations. This is now the challenge we are facing, and this requires a certain integrated system landscape which enables us to go from engineering directly to operations, because this is currently the bottleneck we face in the industries from every process industry, from oil and gas to chemical to pharmaceutical. Next thing I already addressed on my first slide, so increasing complexity. I think this is naturally, we heard a lot about that, but what does this mean? This results into the requirement of shorter project times and faster time to market. Why? We all have to justify our invests, we have to save our invest, we have to add additional value to our projects, to our executional. One of the next challenges is that we are facing heterogeneous landscapes. Not only from IT, so from software perspective, but everywhere. Globalization, we are working with with all regions all around the world, and this of course is again with respect to time zones, applications, etc., a requirement and a challenge we have to face for the future when it comes to operational excellence. So what does this mean? We still need to focus on consistent, up-to-date documentation and of course reusability. Many tasks from the engineering as well as from the operational perspective are repeatable tasks. There are certain workflows, certain guidelines which have to be implemented in a certain manner to guarantee operational excellence and also to minimize human failures in the future. Of course, then one of the last market challenges right now is reliability-centered maintenance, which results, again, in a seamless data handover, which I would like to explain in one of my next slides. Having a look at just as a timeline, what happens right now. For us, operational excellence starts in the engineering phase already. Why? Because all amount of data, which is later on utilized and needs to be used in the operational phase, is generated during engineering. And here already comes the challenge. The challenge is various EPCs, various engineers, and various departments have to work together to make one plant happening. While executing this plant and while closing the engineering phase, a certain handover happens to the owner-operator of the plant itself. The main challenge here, what we face right now, is that every information is reformatted. By nature, every reformatting results in loss of data. Loss of data in any ways. If you convert a Word file or an Excel file into a PDF file, you lose data. Same for any kind of formatting we see in the market. Every reformatting is a data loss, which again will result in problems and issues to consolidate during operations. So this overall situation which we are facing right now results in not efficiently manageable data for the maintenance and operational phase of a plant. Having a look at the technical processes operators have to face and what kind of various departments are involved and what kind of decisions needs to be made. We see that so many departments, so many requirements and so many demands are on the operator side, which needs to be considered while executing, while deciding a certain operational task. It's not only managing maintenance, it's about human resource, it's about safety, it's about environment, and it's even about ERP solutions to maintain the overall stock you have in place. Now, having a look in a nutshell, for operations itself, it is every time a cycle. What we have heard also yesterday with respect to engineering and operation, it's also the operational cycle itself. Excuse me. So it's from the analysis of the actual data, which is currently generated in the plant as well, compared to the data from engineering, to the pre-planning of the maintenance and operational tasks, to the execution with the respected work permits we heard yesterday, or certain documentation required, to the execution, which is sometimes also a pure engineering task, and later on to the analysis again. Now, having one idea to overcome these challenges and to reduce the overall run times as well as to increase the flexibility of a system, I think this is a pretty easy approach. Having one central data model. This data model is built up during engineering phase and is utilized during the operational phase again. So with this kind of approach, we will minimize and determine the overall challenge we have faced in the beginning, so the manual handover of data from engineering to operational phase. What does this mean? If you have one data model, however it will look like, you can derive all kind of information from engineering to operation to as-is data, to data which are tracked within the system itself by DCS, for instance, which are the trigger later on for further operational tasks, maintenance, and engineering for revamp, overhaul, or repair. So we also talk about a cycle. So this data model is the basis for the operational center, which then will have a certain impact on the plant itself. Key points here is information, of course. Information is only valuable if you can bring it to knowledge, because knowledge is something which gives us the opportunity to achieve operational excellence, because we can learn from the past to make it better in the future. Then, of course, decision making based on historian data is one of the key points as well as taking respective actions based on a certain event. Having a more inside look, how will it look like from IT perspective, let's say. Right now we are working in islands. So the overall environment is broken down to islands. There is a certain engineering solution for electrical, for process, for mechanical, even for, let's say, generating data sheets or any lists. And this is one gap where we again lose data every time we would like to hand over and we would like to enhance our performance with respect to operational excellence later on. Now the idea is to have one centralized model, as mentioned in the first slide, which combines engineering, operations, and ERP. Of course, there will be no one solution directly available which covers everything. Because if we especially have a look at ERP and operational engineering, it's the two worlds which have overlapping parts during operational phase and even engineering phase. Now what has to be done is the consolidation of these applications to enable a nice and smooth, seamless information flow between all of this, all of these softwares, for instance. This can be only managed if there's one particular data formatting available in one consistent system where they communicate to each other. Value out of this is shorter engineering cycle, of course, because it forces people to talk to each other. Right now, different departments work independently, and only when it comes to a certain revision or a certain update, they have to communicate somehow. If we force engineering departments to talk to each other directly, face to face, the engineering cycle will decrease tremendously. As a result of that, of course, we lower significantly the project cost. I mean, this is naturally if people are working more efficient on one consistent system, they are more efficient because there's no further interaction required, like email, fax, telephone, whatever. So it's directly on the point, the information. Faster time to market results out of this as well, so I will not dive into that too deep. And here it comes now into picture, lower maintenance costs. But why? As I mentioned before, maintenance is out of knowledge which you gained over the time, as well as the resulting engineering tasks out of certain events. If a pump needs to be replaced, we should know, does this pump failed earlier and why? And this results then maybe in a different engineering manner. If we have to replace a pump and we know that it fails after so-and-so hours because this vendor does not fit my certain industry, for instance, because too much vibrations, whatever, then we have to know this. And if we know this, this has an impact on the engineering later on as well, so that the cycle is closed again and we use all information available throughout the overall operational cycle. Now, how does this look from our perspective, just in generally as an idea? We have heard yesterday the object orientation, which is a great approach, because object means you have one central location where you feed all information in from, let's say, from engineering the feed stage when the idea is born, to the detail engineering phase, to the commissioning, to the operational maintenance, down to shutdown. Everything is in this object. It's like a cubicle. This cubicle has n sides. N sides because every discipline has its own side, his own view on the things as they are. The beauty about this is it doesn't matter from which side you look, you have all data available even from the other side because it's stored inside. Now the value behind this and the idea behind this is that giving tag IDs, what you see in the left corner. Tag IDs, if we have a look, is generated one time and then spread to all disciplines automatically because it is one cubicle viewed from various sides. So it doesn't matter if it is about 3D, electrical, or maintenance later on. And this is a chance to derive the information and to utilize the information from engineering for operational parts to utilize everything what has been generated before. Now, how does it look like in the overall cycle? So on the left-hand side, we have the complete engineering cycle with a certain impact. There are interactions in between. But if we have an object-oriented data model, as shown in the previous slide, we see that all these departments are more or less linked together. Linked is not the right word because they are working actually on the same model, but from various sides. Now, catching up what we heard yesterday as well, about how we do engineering and operation right now, as it is shrinking together, coming parallel. And this is an ideal view now, that we are moving it together to a more parallel working of all the disciplines and later on having a certain handover to the OPEX phase. What does this mean? If we have, what you can see in this picture is all the different disciplines contribute to the overall view of the plant itself. This information results automatically in OPEX savings. As I mentioned earlier, every information which can be modified into knowledge is an easier decision making throughout the entire plant life cycle. If it is an alarm which comes from the DCS system and triggers a certain event to be carried out with respect to maintenance. These information over the time become a certain knowledge base which gives you the possibility to generate preventive maintenance based on actual data which you have generated over the time in one consistent system. And this is the beauty about it, about this idea. Because right now we have many storages, many information stored everywhere and nowhere, and getting this information at the right time, we heard yesterday from BPCL, milliseconds. We have to deal with this also from the other perspective. This was now a drastic example, but in generally time to take the right decisions can only be saved when we have it all consistent in a certain manner. Now, I would not to spread it too much. So conclusion from our perspective is what we already heard yesterday, the digital enterprise process. In the background, can see a little bit the overall picture where it should lead to. It's a cycle, one system, everything involved, but of course with certain connections to other systems due to the fact that we have in some cases only overlapping, etc. But in generally, heading for digital enterprise processes is, from our perspective, the future from not only engineering, but also to get this information to guarantee operational excellence in the process industry. So what does it mean? It means to have a global data center for efficient risk-based industrial maintenance strategies. I just mentioned with respect to historian data, which will turn into certain decision-making points for future tasks. Consistent documentation because of missing handovers of data from engineering to operations and from operations to engineering back, as well as overall KPIs and analysis enabling improvements and change management. Every plant is moving all the time, and these changes need to be tracked because otherwise it will be not possible to take the right actions, to take the right decisions in one of the next occurring cases. And of course, easy portable and direct electronic feedback on site. We heard it several times, iPads, smartphones, even operator stations just with the web interface. Everything like this, these kind of communication should be enabled as well to enable everybody to be flexible. On the other hand, the source for this data, which is derived on the mobile device, for instance, should be stored at a central location only to guarantee the additional value and benefit. What do we gain out of this approach, this general approach is quite easy. We gain shorter amortization period and lower maintenance costs. A plant is productive when we can lower the cost overall and when we can increase the efficiency. Efficiency can be increased only if we know our plant to the smallest nut and bolt. If we know it up to this extent, we can predict certain tasks, we can interact before an accident happens or before an event happens, and this gives us more strength on efficiency on our plant and guarantee operational excellence for the future. And of course, based out of this, we get the respective documentation, everything completely in one system to fulfill certain requirements such as FDA and HSE documentation and requirements to also fulfill all regulations, if it is governmental or from any other organization. And with this, I would like to thank you for listening and wish you a nice day ahead. Thank you.